So I'm Rick Abair with Siemens Government Technologies, and I have a model of a Rubik's Cube. Now, the way a Rubik's Cube works is kind of interesting. There's this piece in there called the center mechanism, and to the center mechanism I've got center pieces, and the center piece is constrained to the center mechanism. So the way it works is, notice that the white piece can never move. So those center pieces can only rotate, they can't move. And the same thing on this blue side. If you see it, it doesn't actually move, it just kind of rotates. So that's what the center mechanism and center piece do. So for instance, if I were to come, what I did is I constrained the center piece to the center mechanism such that it's concentric, so I can rotate it, but I can't rotate it out of plane, and I can't move it out of plane. The only thing I can do is just rotate it around. So this is a corner piece. So this corner piece here has 3 stickers, and I bonded the 3 stickers to it. So if I move either the sticker or the piece, they all kind of move together. So if I pick all the stickers in plane here on the red, now I can rotate this around as a package. And because of that center constraint, I can only rotate it. I can't rotate it out of plane, can't move it out of plane. But I have to know to stop at 90, otherwise the mechanism will lock up. So now if I just pick these, and it doesn't matter if I pick the stickers or the pieces, but if I pick the stickers, now I can rotate those around. So I thought, well, that's kind of interesting. Let's see if we can automate that. So what I did is I put a user interface on this. So now when I say rotate the right side, this green sticker over here is the right side, so I know where that sticker is. All I have to do is go find the 8 stickers in plane, and it's going to rotate those at the same time. So now if I were to do, say, an upside, it knows where this sticker is, it's going to find it, and it's also solving it in real time. So let me do an upside rotation. So now it's solving this in real time. And what it's doing is it's calling my NX open code, and I wrote this NX open code using C#. So this code is doing taking arguments. For instance, it's rotating a face, doing random rotations, and solving the cube. So let me bring up the documentation. So it says here, the Rubik's Cube will be solved using the Cosiemba two-phase solver. So if I go to the Cosiemba website and look at the two-phase solver, here he talks about the algorithm that he's going to use. The algorithm was written originally in Java, but I found on GitHub this port of it by a gentleman named Matt Colburn, Megalomat, where he converted the Cosiemba two-phase algorithm to C# code, and I incorporated that into my code. I take no credit for the solve, I just take credit for putting it all together. And in Rubik's Cube world, God's number is referred to as if God were so inclined to solve a Rubik's Cube, it says here that you can always solve it in 20 moves or less. So the Cosiemba two-phase algorithm can solve this, and here is his proof page, and I will leave that to the reader to go and read that themselves. So if we look at my code, the actual moving of the NX stuff is all NX open, but then over here, these K routines, K search, this is all that stuff that Matt Colburn put together. So I take no credit for the solve, just putting it into NX open. Okay. And even though we can set it to 20 steps, I set it to 21 steps because when I leave it at 20, sometimes it takes up to 40 seconds to solve on my laptop. Oftentimes it's under a second, but sometimes it's 4 or 5 or up to 40. So if it's dialed in at 21, it's never more than half a second to solve. So now every time I rotate it, for instance, if I rotate the left side, now it sees this, and it's not just playing the sequence back. For instance, if I give it 10 random rotations, it really is 10 random rotations. This isn't prearranged. But there, it's now solving the cube in 21 steps, and it took 650 milliseconds, or just more than half a second. If I give it 10 more random rotations, now it's still 20 steps. Well, it went from 21 down to 20, but it really is solving it. So now if I were to do 100, what I'm going to do is speed it up really fast. So this is really and truly 100 random rotations, not some predefined thing. Anyway, there, it finds it in 21 seconds. So I'll go ahead and do a couple of more. I'll just randomly pick a couple of more. And you can see each time it's done, it solves it. And then when I have to say, just go execute the solution sequence, we can keep track down here. It tells us what's happening. And there, in my CAD system, I've solved a Rubik's Cube. Can your CAD system solve a Rubik's Cube?